I will talk in this video about how to use R software to analyze your questionnaire. At first you have a questionnaire and you have the data out of the questionnaire and you want to use R. R is free. You can use of course Excel or Minitab or SPSS. However, R is not bad and it has a lot of different characteristics and advantages that you can utilize. I would like to cover the following topics. At first, summarizing the responses in Microsoft Excel, and of course, reading data by R, Cronbach alpha, one sample t-test, and for each item and for groups, and also for particular respondents, and two sample t-test. Let us see. Here is R. At first, you define this library. Open Excel, then you set your path. For example, I have this path, so all what I have to do is to go to my folder and copy this one. When I copy it, I go here, and after copying it, I put, for example, this one. But as you see, it is not exactly the same as this one here, because I have to replace this with this for all of them. For each one of them, I have to replace this with this. But since it is already above, we don't need it now. And set WD is to set the path that is needed to read your data. Then you have to read your data. This is why we defined the library here. So data read workbook. So you put the name of your Excel file. Here is my Excel file, for example. And as you see here, some data that are, of course, in from a questionnaires. They are in Excel, as you see. For example, this is the respondent number 1. He is from Abu Dhabi, and he is expert. He is professional, and he has the following answers for his questionnaire. For example, for the first one, he sees that financial support has a high rating. This is a Likert scale from 1 to 5. 5 means strongly agree, and 1 means strongly disagree. So this row is only for one respondent. The second row is for another respondent. For example, this respondent is resident, so he is not a professional, and he is from Abu Dhabi. He has this view, which is agree about financial support for renewable energy, for example, supporting investment. He thinks it is very good, so he strongly agree about that. But for this person, he strongly disagree about policies and strategies, for example. And now we want to analyze such data. So we go here and we will read the data. So we use read workbook and put the name of Excel file here, .excel, and the sheet name is sheet number 1, and column names equals true. And this is why, because we have here column names. So we put this, and anything that is after the hashtag will not be read. So anything here has nothing to do with the programming, just for you to give yourself some notes. For example, the sentence here, Cronbach alpha. What is Cronbach alpha? Cronbach alpha is something to measure the internal consistency of your items. For example, if you have 4 items and all of them belong to some one subgroup, then you want to put them together and to measure if there is internal consistency of them or not. So to measure that in R is very simple and straightforward. These are the 4 different items that I want, which is financing, this row or this column, this column, this column. I think they are 5, or yes, they are 4. and I want to put them together, and I claim that this column, this column, this column, and this column, all of them are measuring one subgroup. So to check that, you need to make Cronbach alpha. How to do that? At first, I made this let us say part of the data, which is called data financial support policies. So you go here, for example, what its name here, and read them. So here are the results, as you can see. So let us go back here again, and you want now to check if they represent the same thing or not. All what you need to do is, of course, to write this one, Cronbach alpha, then the name of the data, and finally this dollar alpha, for example. Let us see how to read them one by one. To read each one by one, you just click Control Enter. So as you see in the bottom part of the screen, then another one, Control Enter, another one, Control Enter. So I read the data now. Then I go to this library, LTM, then define the data that I need, and finally to find the Cronbach alpha. As you see, Cronbach alpha value is more than 0.7. As long as it is more than 0.7, it's okay. If it is not more than 0.7, then you must rethink about your subgroup. Maybe they are not, or they do not belong to the same subgroup. So now we want to talk about t-test for each item. So I defined this matrix. How to define matrix? You need to write them, to write it in a certain way. For example, I use this way. So t-test data, the matrix, all the values of it is 0, and the number of rows is 8, and number of columns is 1. So if you want to see the values of this matrix, you just type its value here and put enter. Now all of it is 0. We don't have anything right now because I put the value here 0. Now I want to add the row names, and these names are exactly as these columns. For the mu0 equals 3.5, actually you can set it to be 3 or 4, whatever you want, but I chose it here to be 3.5. So I want to check if the average of the data or the average of the Likert scale is more than 3.5 or not. If it is more than 3.5, I assume that that means that the respondents agree about these measurements, for example. Now, to make the t-test, you can use complete cases. This is to test if there is a missing data or not in the data. So if you check, sometimes you can find some missing data. So you can use a complete cases to check that. And here is the for loop to check all of them, all these four, from the column 4 until the column 11 in Excel. And you want, that means that you have actually 8 questions, and you want to check if each one of them is more than 3.5 or not. So this is how you write that t-test, and you put at first the data, and then mu equals mu0, and the alternative is greater, and you want, of course, the p-value, which is the most important thing, but you can also get other things here. So after that, you can make a t-test for a group of columns. That means that if you have, for example, 4, as we have seen before, we have, for example, here we said that we have actually 4 measures, and these are the 4 measures, and you want to see if these 4 measures actually, as a subgroup, if the average of that is greater than 3.5 or not. The same idea here also, but you make the raw means, and you want now to check this average, if it is more than 3.5 or not. The same thing is here, but now we want to differentiate if we have actually there is a difference between professionals and normal residents. For example, here is to only choose the professionals or not to choose the professionals, that means residents, because here it means not equal. So if they are not equally professionals, here's the position, here's the position. If the position is not professional, or in other words equals resident, then it is of course the normal residence, and you want to check now to do the same thing to check if the normal residents are more than 3.5 or not on a Likert scale. The same code actually here as before, but we have now only the normal residence. Then you can make one sample t-test actually for the professionals. Here it is for the professionals. So now we have equal instead of not equal, and do the same thing to get the results. And here two sample t-test. Now we have two groups. The first one is two or data professionals. The second one is data residents, as you can see here. And now we want to make the t-test or two sample t-test, and that is the same idea here. We have the complete cases for the first group, the complete cases for the second group. And now to make t-test, just write t-test like here, t-test, and then data 2 and data 3. What are data 2 and data 3? Data 2 is the professionals and data 3 is the professionals. Let us see that, or just make the whole things together. Let us see. Actually, there was some mistake here. So let us see all of them together. You can just click on Control Enter. Now you have everything if you want. For example, if you want to get the results of this one, just you can click here and get the results. As you see that for financing, they are actually different. For infrastructure, also they are different. Why? Because this is the p-value, and the p-value of it is low, then each null must go. That means that they are different from each other. That means that, for example, we have two groups, the professionals and the residents, and they are actually different regarding these two dimensions. Yeah, that's it. Thank you very much.